Hi friends, this is Soft Reason. You are welcome. In the previous lesson, we stop here, and so we will have to continue from this place. Okay. Uh, at this point, we have added our load on the polines. So let's just check it. Okay. We have applied load to this poline already. Okay. So if you check these polines, okay, under load, okay, you will notice that you have a load of 3 minus 3.0 acting in the z direction, this upper direction, okay, but it acted downward, okay, and then also we have a minus 4.0 kilonewton per meter, okay. So these are the loads group, okay. This can be applied to the structure, okay. So the next thing we will have to do now is to we are going to edit the materials, okay. We are going to edit the materials, and for us to do that we will have to go to analysis tab, okay. Go to building analysis, okay. Alright, so in the building analysis dialog, you check the parameters, okay. These are the codes we are using for the steel BS 5950, and for the concrete we'll be considering this code, and for the loading this code, okay. So we'll go to the foundations, and then we are going to take the foundation to be 120 kilonewton per meter square, okay. And then we will you can give it any title at all, okay. It's a warehouse design, all right. So you click on the okay. All right, so you check this loading, you notice there is no loading here, so you have to generate loads, okay. So you click on okay to generate these loads, okay. Factors for the design of the reinforced concrete, okay. So you click on okay. All right, so in this case we are not going to consider the wind load, otherwise we could have be able to edit the wind loads dialog, okay. So you click on edit material. In the edit material, what we are having is columns, okay. So you edit the diameters of these columns to be 16, y16, and y20 as well, y25, okay. Right, so the program we select the one that will be suitable for the design, okay. Click on okay. The next thing we have there is the beam, okay. So you click on the y16, okay, y20 as well 25, and click on OK. We are also going to edit the steel columns strength, okay. We are going to use a 275, okay. 275. I can see 235 here. We will change it to 275, okay. You select this one. We are going to use 275 for all the steels, okay, for the sake of economy, okay. Just like this for the steel, okay. Alright, so let's go to the foundation. In the foundation we will be selecting white dwarf, okay. Alright, so and 16, just 12 and 16 for the foundation design, okay. Click on okay. Alright, so the next thing we do, you okay this, you open this point again, then check the links, okay. We are going to use y8 and 10 as our links. Click on OK. Alright, so having set all these materials, what we need to do is we will close this. Alright, so we have set all the necessary materials, okay. And so the next thing we need to do is to run the analysis of the structure. So you go to analysis, but by then you have to save the project. Alright, after saving the project, you go to analysis tab, rebuilding analysis. In the dialog, move straight to analysis. Okay, you ensure that you check the steel member design check. Okay, check the beam reinforced design and the columns reinforced design. Okay, after which you have to start analysis. Steel member design check. Okay, checking the designs of the steel member. All right, so analysis is successfully done. Okay, so click on OK, and then after which you go to the post analysis. Okay, the post analysis, let's see the behavior of the structure. Okay, so click on this model and analysis result display. Alright, so once you click on that, you have this. Okay, so you can see the deflections here. Okay, these are the deflections in respect to the load applied on this structure. You can see the steel purlines being deflected based on that load applied. Okay, so if you want to see the animation of this structure, you just click on this animation. Okay, so you can see the animation. Okay, based on the load applied. Okay, this load is being applied on the purlines, which it will now transfer it to the trusses and onto the columns as well as the tie beam. Okay, so this is the behavior of the structure. Okay, so I will have to stop the animations. Okay, we want to check the bending moment. Okay, the shear force. This is the shear force. Okay, you can see the shear force of the structure. Okay, so you want to check the bending moment, you click here, you see the bending moment of this structure. Okay, all right. Okay, so the next thing we have to do, we will leave this particular interface. Okay, we'll close this, and then we will also close this. All right, so we will now be checking our members if they are actually designed. Okay, if the design has passed. So the first thing we have to check this polyline. You click on the polyline. Okay, you right click and then click on the steel member design. Okay, alright, once you click on it, this is what you are having. Okay, you can see the information here. You will notice that the utilization ratio is failing, 6.5 less than 1. Okay, it's failing. Okay, that is why you are seeing this. The utilization ratio in respect to Azure tension check has actually passed. Okay, alright, so if you notice you discover bending check. Okay, it's also failing. Alright, so you can see shear check. Okay, in the y direction is also failing. So how do we make these things to pass this design? Okay, so that is what we will be doing now. Okay, so we will look at we check design again. Okay, you check design again, everything is still the same. So what we need to do is to we are going to change the section. Okay, you click on this change section. Okay, so you are having this. Okay, this is 100 by 50 by 10. Okay, so we can now try 25. Okay, try this and then you select it. All right, after which you click on OK and see the changes. All right, you see this one has passed. The utilization, the U ratio in the minor Y, okay, has just passed. Okay, based on the changes we have made. So we have to still increase this, to still have to overcome the Azure compression check, okay, and also check for combined forces, okay. uh, Also the Azure tension check has passed, okay, so we don't have issue with this. If you want to see the details of the calculation, you click here, you can see, okay. All right, so the slenderness check is failing. This is even giving warning, okay. So this is 242.39 is greater than, okay, so it's supposed to be less than this, okay. So what we need to do, you click on the change section again, and then you click on this point. Mind you, we are using the British standard, okay. So what we need to do is to increase this section to 180 and see what happens. Okay, you select it and then click on okay. All right, so once you click on OK, you notice that the utilization ratio under the compression check has passed, okay, but the slenderness is still giving warning. All right, so we want to also increase this member, okay. So you click on change again, and then you click on this. We want to use instead of 175 180, okay, but we want to use 90 and 26, okay, and see how it works, okay. All right, so we can see now all the check has been passed successfully. Check for combined forces, you can see all of them has been passed successfully. So this is how you can edit your members based on the load applied on these structures, okay. If they actually failed, you can see the code, the design code, the BS 5950, the effective length, and all of the parameter, the length of the polars, okay, are being given here. The section class, okay, class 1, okay. So this has been checked and then is successfully designed now. As you can see, you want to print the report, you just hit on this report design, okay. Once you click on this report design, it will actually show you the report that you can't successfully print, okay. So this is your report, okay. You can see this tip line SP1, okay. Section is this, okay. Now it's selected the strength of steel 355, okay, but this is one of the strength we selected. 275, okay. So after analysis and design, the program also select this, okay. So this is the report for the Polaris, okay. So you can just print it either in PDF on in Office, okay. Close this and also okay here, okay. So the next thing we want to check is the thrusters, okay. You click on this thrust, right click, and then you click on the steel member design, okay. So you notice something. This is the thrust, okay. You will notice that the top chord is failing, okay. You can see top chord is failing here. This one and this one is failing. This one has passed, okay. You can see the vertical braces. These are the vertical braces, okay, all pass, okay. There's no problem with that. All right, and then the diagonal braces also pass, okay. If you check, the bottom chord is also failing, all right. So the next, what we need to do is we will have to increase based on what is failing and what is passing, okay. So if you click here, you know it is back to back. So the bottom chord now consists of 4 different kind of member, okay. All right, 2 this way and 2 this way, because it is back to back. That's why you are having under bottom chord you are having 1 2 3 4. This and this combined together is failing. This and this combined together is passing, okay. So what we need to do is to select this. Once you align this, the next thing you do, you come to let's change the member, okay. So we are still using back to back. You click on this. All right, so instead of it's still 100, but instead of 65 by 7 you use this, okay. All right, you use the 75 by 8, all right, and then you click on select and click on okay. You can see it is still what failing. All right, so you need to change it again, and then you use this, okay. You use this and see, click on okay, and then you click on okay. All right, this is passing and it's also failing at the utilization ratio, the slenderness ratio. The thickness we have increased has overcome the slenderness check. Okay, but the utilization check now is still failing. Okay, so what you need to do, you go back, all right, and then you activate this, and then this time around you are going to use 120 by 120. Select it and okay, let's see how it works. All right, so it is not still passing. So what we need to do is go back again. All right, click on this point and then we will have to check here. We have to check here and then we select here. Okay, so we check this point, and then activate this point. We use this, okay, this time, and then select it. This one has passed and this has not passed, so you go back. Okay, at this time you're going to use this one is the thickness. Okay, so you select it. Right, you go back again. Let's check this thickness. Still not pass. We check this. It is the utilization ratio that we are considering. Okay, so utilization ratio is failing at the combined forces and at the compression check. Okay, so what we need to do, you come to section again. We're having this, let's use this thickness. Here is that thickness, let's see. Alright, so we're having this tenderness check pass. Okay, what we have issue with is utilization ratio and then the utilization ratio at this compression check. Alright, so let's see, try this thickness. Alright, so you can see all has passed now. Okay, we have finally gotten all passed, the check for combined forces and the rest of the forces. So this is how you can change your sections. Okay, and then you do a check, design check on it. You see all has passed. Okay, section class is class 3. Alright, so we'll close this. So we have designed this truss successfully. Okay, oh, I can see this place is still failing, so let's check this place. Okay, alright, so what we need to do is we will go to this, select this, we will use this one and use this one. Okay, we are going to use this thickness and then we select it and okay, it has passed. Alright, so we have done with the trusses. Okay, so click on okay. So the trusses has been designed successfully. You can see, you want to print your report, click here to print your report. If you want to number the trusses, you can see, click this point to number it, or to show your utilization ratio on the trusses, you click there. Okay, deactivate this. These are the utilization ratio, okay, on the trusses, okay, on the members. So that is how it works. Okay, I click on okay. So these trusses and the poline have been designed successfully. So the next thing we need to look at is this tension. Okay, right click on it and then you select the steel design. You will notice that the check for combined forces is utilization ratio is failing. Okay, while other shear check and then compression check, everything has passed. Okay, slenderness check too has passed. Okay, so the next thing we do, we need to work on this so we can make this pass. This section class is class 2. Okay, the design code you can see. So what you need to do is you will have to click on this section, okay, and then you click on the this point. Okay, so you, instead of 46, you use 52, okay, to see if the thickness can help and assist the structure. You can see the utilization ratio now has passed, okay, just that we increase the thickness of the steel stanchion, okay. So you click on the okay. All right, so we have designed this steel stanchion successfully. So the next thing we will look at is these braces, okay. Click on it, and then you have to click on the design check, okay. So if you look at it, you will notice that this one are actually failing, okay. The compression check and the combined forces, okay. So we want to edit it as well by selecting another section, okay. If you want to use this one 40, okay, you select this. You notice it is still failing, okay. So we'll go back, okay. I'll click on this, okay. So 40 by 3, so we'll use this and see, select this and okay. It is still failing, okay. You can't withstand that load, that pressure that is coming from that angle of the structures, okay. So you have to increase the member from 40 to 45, okay. At first you check it after you increased it. All right, okay, it's still failing, so you go back, okay, and then you click on this point again, and then you may select this, okay, thickness, okay, and then you click on select and okay it. All right, it is still giving us warning, okay. So what we need to do is let's quickly go to 50, okay. 50 by 6 by 5 by 3.77, okay. Select it and then okay. All right, so it has not still passed. Go back to change the section again. We are going to use this time around, we are going to consider this, okay. Let's consider this before going to 60, okay. So you click on this. All right, so you can see it has passed the design. All right, but the slenderness check, slenderness ratio is still giving some warning, okay. Because actually this is not supposed to be slender as expected, okay. It's just because we are not divided the braces into two, okay. That is why it seems slender. So but even at that, let's try to check the equal angles using 60 by 60 and see if you can withstand that slenderness, okay. We're having 318.57 is greater than 200, okay. So if we want to actually overcome this, we use a thickness, a braces thickness that is about 70, okay, by 6 by 6.8. Let's see how it will overcome that. It's giving us 227, okay. Let's check. Let's try 90. 211. All right, let's check 2. All right, 90 by this thickness and see. Okay, 217. Okay, so that is to say 100 by this may pass the design. Let's see. All right, so you can see it has passed. So the braces has been designed successfully. So click on okay. But if this braces you are seeing here, if this braces is divided here, you will notice that and then it is all by connection, okay. It is all by splice connection, so it may not necessarily cause that a failure at that slenderness, okay, because it is the length of this that made it slender, okay. Are discussing that failure, okay. So this has been designed now successfully. So how about this roof brace? You also have to check it to ensure that all are using design successfully. Okay, the share check is okay. What is not okay is the compression check and the combined forces. Okay, and this is very far from 0.1. Okay, so if you want to select a material to withstand this, what you need to do is you have to go for higher material. Okay, so you can go for a material of this 150 by 8. all right it has withstand that. Okay, so you can also reduce it, depends. I'll reduce it to, since we are using 150 pass, just try 120 and see if it will also pass. All right, 120 also pass. You can see how you reduce to the material to reduce the cost. Okay, so you can also try, if 120 has passed, you can also come to 100 and see if 100 will actually also pass the design. 100 did not pass, so you go back and then you can still use 100, but you change the thickness. Okay, this is 100. Okay, change the thickness to this and then you select it and okay, you see it has passed. Okay, with that thickness, this is still the same 100. So we have also designed these braces up here. All right, so we have done with the design of all the steel members. Okay, so the next thing we will look at is this concrete member. Let's actually design this concrete member. So we want to see if the reinforcement selections. Okay, so you see you are having a 3y13 up, so you can just make it 3y16 up, top and bottom. Okay, so you click on okay. All right, so we have done with the steel and the concrete design. Okay, so the next thing we want to do, let us actually check the load that is coming from this steel structures to the this column and onto the foundation. Okay, for us to check that, we have to navigate to the story one. Okay, you go to story one. Okay, and then you navigate to the plan view, and at first you have to save the structure. So after saving the structure, you will need to navigate to the story 0. You have this at the story 0. So we want to check the loads that is coming from the steel structure. So we'll come to this point and activate this point. Okay, and so while that point is activated, the next thing we will do is column plan display. You click on it and then you click on the Azure Load. Okay, once you click on the Azure Load, you have to select the load that you want to look at. Okay, so you want to look at this one, G factors, F and G factors. Look at this one, are you okay? Then you click on. If you want to check also bending moment, you check bending moment at that point. Click on OK. Right, so it is not displaying. Or we'll go back and then check this. We'll have G plus Q, G plus let's check this one, and okay, so you can see the loads coming to this column is 364.2 kilonewton. Okay, the moment is this one. Okay, that is this column. This column is carrying 382. Okay, so these are the loads that come from the steel structure to the foundations. Okay, this one and this one are the same thing. So this one and this one, because they are symmetric. Okay, so this one and also this one as the same thing. So we'll be using this load to design the foundation. Okay, all right, so what you need to do is the foundation we are going to use is a strip foundation. Okay, so now we are at the foundation level. Okay, so what we need to do is we have to save the project first. Alright, so after saving project, we want to insert our beam. You click on beam. Okay, and then the thickness of our beam is 300, and then the height of the beam, it will be 400. Okay, so we click on this point, and then click on this point, click on this point, click on this point and this point to insert our beam. And also we need to insert beam at this center so as to bind or tie the structure at the midway. Okay, so after which you close this. All right, after you close this, you have to insert your foundations. Okay, you select this beam, select this one, select this one and this one. Okay, once you select this four beam, you right click and then insert the strip footings. Okay, so once you click on that, you check the design envelope. Okay, so this is the load you are considering. Okay, the load combination we are considering. We want to select white wall for our foundation design. The footing depth we want to use 350. Okay, 350, just like this. Okay, all right, so the cantilevers we're going to use a 1000 cantilever. Okay, so we click on design. This soft grade reaction coefficient still remain the same. Okay, so after the design, you can see this, the design has been carried out successfully. You click here, you print your report for this strip footing design. Okay, you can see, so you click on OK, and then you click on the OK to insert the strip footing. You can see this is it. All right, so you do the same thing here. Click on this and this one, this one and this one. You right click and then you insert your strip footing. Okay, so you click on the design envelope. All right, you also change this point to 350. Okay, you change this point to 350, just like this. Okay, so after which you select this footing bar size to be 12. Okay, after which you have to click on design. Okay, click on design. So this is as this has been designed. Okay, all right, based on the elastic method of design. Okay, so you click on OK, and then you insert this strip footing. You did the same thing here. All right, so click and then you select your insert footings. So in this dialog, you will do the same thing here. You will put 350. Okay, and you will select a white wolf here. All right, check the envelope and then click on design. All right, so this is the design moment and shear force. You can see them and the load. Okay, applying on the column, from column 1, from column 2. Okay, and then you click on what? Okay, and OK to insert it. Do the same thing here. Strip design. All right, so click on OK, OK it, and then you do this last one. Alright, so the foundation has been designed successfully. Let us navigate to the 3D view of this model to see how it looks. So this is what we'll be having. Okay, Alright, so we have successfully done with this truss design. We have also done with the steel stanchions as well as the polines, and including this foundations design, just like this. Okay, so this brings us to the end of this lesson. Okay, so if you have not subscribed to this channel, this lesson must have helped you in one way or the other. Subscribe and stay tuned for more advanced lessons of this kind. This is Soft Reason. Bye for now.